Hello friends, this is Shubhra from justtutors.com. So this is the fourth video from the lesson of metals and not metals. So let's get started and see what we are going to do in this video. So in this lesson, we are going to learn about the extraction of metals, refining of metals, and more about the corrosion. So first of all, extraction of metal. So we know that the metals are found in the earth crust in the free states. Some are found in the form of their compounds. So metals like gold, silver, platinum, copper are found in their free state as they are least reactive and they are found at the bottom of the reactivity series. As you can see here, while the potassium, sodium, calcium, zinc, iron, all they are being found in the form of the compound in their sulfide form or the carbonated form. So we're going to extract them in that. And we use different process with the most reactive atoms like most reactive metals and then with the less reactive metals. So let's learn more about that. So here we have several steps involved in the extraction process. So first of all, metals of the high reactivities require the electrolysis process of their molten ore to get the pure metal. Then metals of the medium reactivity use the process of calcination or the roasting to get the pure metal. Then the metals of the low reactivity, if they have the sulfide ore, then we use the process of roasting. Otherwise, you can use the heating process to extract your metals of low reactivity. So ores of many metals are the oxide because oxygen is available in the abundance on earth and is very reactive element. So we're going to use that oxides by extracting the pure metal. So we can use the process of heating or we can use the reducing agent for that. So let's get started with the extraction. So extracting metals slow in the reactivity series. So for that we use the heating process. So the oxides of these metals are being reduced to metals by heating. First of all, we heat the sulfide ores, so you get the oxides form, and then we again heat them, so we get the pure metal. And here is the example of the mercury is shown to you. So that's a cinnabar, the ore form of mercury has been extracted to get the mercury in the pure form. Similarly, we use the same process for the copper. So here we have the copper sulfide which is being extracted to copper by using the process of heating. Now, the next process we use it for the metals in the middle of the reactivity series. So here we have the iron, zinc, lead, copper that are moderately reactive and they are being found in the sulfide form or the carbonate form. So while you are being heating the sulfide ores to get the oxides of that, the process is named as roasting. Here we have an example. So if you are heating the zinc sulfide in the presence of oxygen to get a zinc oxide, we name this process as roasting. And the second method is calcination, where we heat the carbonated form of the metal to get the oxide form. And after that, the metal oxides are then reduced to their pure metal by using the reducing agent such as carbon here. Now, extracting metals at the top of the reactivity series, the metals have more affinity for the oxygen rather than carbon. So these metals are being obtained by electrolytic reduction, like sodium, magnesium, calcium are obtained by the electrolysis of their molten chlorides, and these metals are deposited at the cathode, whereas chlorine is being liberated at the anode, that is positively charged electrode. As chlorine is holding a negative ion, that's why it's been attracted more towards anode, and sodium has positive ion, it's been attracted to cathode. So let's learn more about the electrolytic refining. So electrolytic process is a use of an electrolysis industrially to refine metals and compound at a high purity and the low cost. So electrolytic process is been basically is used in the industries, and many metals such as copper, zinc, tin, silver are refined electrolytically. So the impure metal is being made the anode, and the thin strip of pure metal is been made the cathode, and the solution of the metal salt is used as an electrolyte. So there we have a simple diagram how we used to do the electrolytic refining, and we have the example of copper here. So the impure copper is been made as an anode, as you can see that. Now pure copper is been deposited at the cathode, and the metal solution we have is copper sulfate solution here. So on passing the electric current through the electrolyte, the pure metal from the anode dissolves into the electrolyte, and an equivalent amount of pure metal from the electrolyte is deposited on the cathode. And the soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom, as you can see here. And that is been known as the anode mud as well. Now, moving ahead with the corrosion. So, corrosion is a natural process which converts a refined metal to a more stable form, such as its oxide, hydroxide, or sulfide. So, it's a gradual destruction of metals by the chemical reaction with their environments. So, all metals can corrode. Some, like pure iron, corrode quickly. Stainless steel, however, which combines iron and other alloys, is slower to corrode and is therefore used more frequently. So, all small groups of metals, called the noble metals, are much less reactive than others. As a result, they corrode rarely. So the only metal that can be found in nature in their pure form include copper, silver, platinum, gold, and palladium. Now, to prevent this corrosion, what we can do? So, to prevent this corrosion, we can use the methods like painting, oiling, greasing, galvanizing, chrome plating, anodizing, and making alloys. So, galvanization is an industrial process that we use for all the metals. Is a method of protecting steel and iron from rusting by coating them with a thin layer of zinc. As iron and steel are being used in the process of making the buildings, houses, so that's a really big thing. So if iron corrode, that can damage the building. So we use this process so you can protect our buildings. Now we have an iron pearl at Delhi. It's a wonder of Asian Indian metallurgy, as it's a 1600 years older, and they had developed the process which prevent the iron from rusting, and they use the method is called amalgamation of various metals along with the iron to build this masterpiece. So now it's a time for the practice questions, so you can pause the video and try these all questions here. And there you go with the answers of your practice questions. I hope you have done a great try with all these questions here. So that's all for this video. I hope you have enjoyed that. For more videos, you can visit justtutors.com. Thank you.